What if I told you that you're already a time traveler, that astronauts have actually traveled to the future, and that every time you look up at the night sky, you're literally seeing the past? Today, we're diving deep into the science of time travel, separating Hollywood fiction from mind-bending reality. Hey everyone, welcome back to Dark Matter Diaries. I'm Sarah, and today we're exploring one of the most fascinating questions in physics. Is time travel actually possible? First, let's blow your mind with this fact. You're traveling through time right now. We all are, at exactly 1 second per second, moving forward through time. But here's where it gets interesting. Einstein's theory of relativity proved that time isn't constant. It can stretch, compress, and flow differently depending on two things: how fast you're moving and how strong the gravity is around you. The astronauts on the International Space Station, they're actually time travelers. They're moving so fast, about 17,500 miles per hour, that time passes slightly slower for them. When they return to Earth, they've aged about 0.01 seconds less than the rest of us. It's tiny, but it's real. Now here's something that'll make you feel like a time traveler. Every time you look up at the night sky, you're literally seeing the past. The light from our sun takes 8 minutes to reach Earth. So when you see the sun, you're seeing it as it was 8 minutes ago. That star you're looking at? Its light might have left when dinosaurs roamed the Earth. The Hubble Space Telescope has photographed galaxies so distant that we're seeing them as they were 13 billion years ago, almost as old as the universe itself. In a very real sense, telescopes are time machines that let us observe the past. This isn't just theory, it's how we discovered the expanding universe. When Edwin Hubble looked at distant galaxies in 1929, he was seeing them as they were billions of years ago. And that's how he realized the universe was expanding. Remember that water planet scene in Interstellar, where 1 hour on the planet equals 7 years on Earth? That's not just science fiction, that's actual physics. The planet was orbiting so close to a massive black hole that time literally slowed down due to the intense gravity. This is called gravitational time dilation, and it's absolutely real. In fact, we use this knowledge every day. GPS satellites orbit Earth at high speeds and experience weaker gravity than we do on the surface. Without accounting for time dilation, your GPS would be off by about 6 miles every single day. Scientists have even accelerated particles to 99.9% the speed of light. From the particle's perspective, it experiences time so slowly that it can travel vast distances before decaying. It's like the particle is time traveling to the future. The fastest humans have ever traveled was during the Apollo 10 mission in 1969, about 25,000 miles per hour. The astronauts aged about 300 microseconds less than people on Earth. But what about going back in time? Can we visit the past like Marty McFly? This is where physics gets really weird. Einstein's equations don't actually forbid backward time travel. In theory, things like wormholes or closed time-like curves could allow it. But here's the problem. Every proposed method requires exotic matter, negative energy, or conditions that might be impossible to create. Plus, there's the grandfather paradox. If you go back and prevent your grandparents from meeting, how could you exist to travel back in the first place? The universe seems to have built-in protection against these logical impossibilities. Stephen Hawking once proposed the chronology protection conjecture, the idea that the laws of physics prevent paradoxes by making backward time travel impossible. He even threw a party for time travelers, but only sent out invitations after the party was over. No one showed up. So here's what we know for certain. Time travel to the future is not just possible, it's happening constantly. The faster you move, or the stronger the gravity you experience, the slower time passes for you relative to everyone else. The famous twin paradox illustrates this. If one twin travels to a distant star at near light speed while the other stays on Earth, the traveling twin returns to find their sibling has aged much more. The traveler has effectively jumped forward in time. As for the past, we can observe it, but we can't change it. Every photon of light carries information from the past, making the entire universe a kind of time machine that preserves history. Could we ever build a real time machine? Some scientists think it might be possible to create time dilation effects artificially. Imagine a chamber that could slow down time for someone inside. Not quite time travel, but close. As for backward time travel, most physicists remain skeptical. But science has surprised us before. 100 years ago, the idea that time could slow down seemed impossible too. Quantum mechanics has already shown us that reality is stranger than we imagined. Maybe future discoveries will reveal new possibilities we can't even conceive of today. So the next time you look up at the stars, remember, you're not just seeing points of light. You're looking through time itself, seeing the universe as it was long before humans existed. And the next time you check your phone's GPS, remember that it works because we understand time travel well enough to account for it in our technology. Time travel isn't just science fiction, it's science fact. We just haven't figured out how to make it dramatic enough for Hollywood, yet. What do you think? Are we destined to remain prisoners of the present, or will future technology unlock the secrets of time itself? Let me know in the comments below. If you enjoyed this deep dive into the science of time travel, hit that like button and subscribe for more mind-bending science content. Until next time, keep exploring the universe